All right, this is calculus section 5.4, exponential functions, differentiation, and integration. We are just doing the differentiation part right now, though. So, natural exponential function is the inverse of the logarithmic function, ln of x. It's e to the x power. So, e to the x power is equal to y if and only if x is equal to the natural log of y. Inverse functions, there we go. So, how do exponential functions work? Little refresher. Remember that e to a power equals 7. To solve that, we would take the natural log of both sides, giving us x equals the natural log of 7. Remember that their graphs are exponential growth, usually unless we do transformations on them, and exponential decay if the base is less than 1. And anything else we might need to refresh together. Inverse relationship tells us about the derivative, that the derivative should be 1 over the derivative of natural log, which is 1 over x, times derivative of the inside, okay, ln of x. The derivative of its inverse is 1 over the derivative of this, which is 1 over x, times the inverse evaluated at y. So basically it tells me they're connected, right? Don't worry about this. Oh, wow. Sorry, I had to write this out differently. Okay, it's 1 over the derivative at g of x. So 1 over x, but instead of x, it's g of x, right? So that means the derivative would be g of x in this case, which is e to the x power, because of the way the derivative of natural log works. So, derivatives of the natural exponential function. The derivative of e to the x power is e to the x power. The derivative of e to the u power is e to the u power times the derivative of u. So let's find some derivatives. Y equals e to the 2x minus 1 power. Well, the derivative of e is e. dy dx is e to the 2x minus 1 power times the derivative of 2x minus 1, which is just 2. Written a little nicer, dy dx equals 2e to the 2x minus 1 power. Y equals e to the negative 3 over x. Well, the derivative is e to the negative 3 over x times the derivative of that numerator. The derivative of negative 3 over x is positive 3 over x squared. So, cleaned up a little bit, our derivative is 3e to the negative 3 over x squared. The relative extrema. So first we need to find our derivative. This requires the product rule in this case. So our derivative, dy dx, derivative of the first piece, derivative of x is 1, times e to the x, plus the first piece unchanged, times derivative of the first piece, second piece, which is e to the x. Now we set it equal to 0 to find relative extrema. I have e to the x power plus x e to the x power. I can factor an e to the x out. Leaves me 1 plus x. Then set each piece equal to 0. E to the x equals 0. 1 plus x equals 0. Well, e to no power will ever give me 0. Remember, I would use natural log here. The natural log of 0 does not exist. That's not giving me an answer. Subtract 1 here. X equals negative 1 is my only relative extrema, my only critical number. Plug numbers into the derivative on the left and right side. Let's say I plug in negative 2. E to any power is still positive. So positive times a negative makes it negative. And let's say I try 0. Positive times positive is positive. We are decreasing, then increasing. We have a relative minimum at -1, comma, -1 over e when I plug in -1 to my original function. All right, now a word problem. Projected population Y in thousands of California from 2015 to 2030 can be modeled by this function where t is the year and t equals 15 equals 2015. So that means t equals 0 is 2000. At what rate will the population be changing in 2020? Rate tells me derivative. So we are going to take dy dt. Well, 3469 is just a constant, so I don't need to deal with it. It just hangs out. Oh, sorry, 696. e to the 0097t times the derivative of that exponent, which is 0.0097. If I want to know what the rate is changing in 2020, that tells me I'm going to be replacing t with 20. I don't even need to bother simplifying this. I'm just going to plug in the 20. All right, this is definitely thousands of people per year if I left it like that, but we won't. 34696 times e to the 0.0097 times 20 times 0.0097. The answer is about 408.606 thousands people per year. It's growing 408,000 people per year. Oof. All right, then you'll practice out of the new textbook.